Okay. Now we are in electromagnetic spectrum questions. I think a few examples. Electromagnetic spectrum examples. And now one more we have to complete about the more two examples I will give. In this, the first one, a particular radio station broadcast frequency, a particular radio station, a particular radio station broadcast at frequency, broadcast at a frequency of, frequency is nothing but nu of 1120 kilohertz. 1120 kilohertz. Another radio station, another radio station another radio station broadcast at a frequency of 98.7 megahertz. 98.7 megahertz. What are the wavelength of radiation? What are the wavelength of what are the wavelength of radiation from each station? From each station. Okay. Now listen. A particular radio station broadcast frequency of 1120 kilohertz. Kilohertz is nothing but 10 to the power of 3 into 3. And another station broadcast frequency 9.8 megahertz is nothing but into 10 to the power of 6. What are the wavelength of radiation from each station? You know already that wavelength equal to, wavelength lambda. The lambda wavelength equal to c by nu. Yes, a c value we know that one, that is the speed of light, c equal to 3 into 10 to the power of 8 meter per second. And here frequency for first one 1120 into kilohertz is nothing but 10 to the power of 3. And for second one, for second station, nu 2, for second station, that is 9.8, 98.7 into 10 to the power of 6. This is megahertz. This value 10 to the power of 6 value for megahertz and 10 to the power of 3 value for kilohertz. Okay. Now solve this one for first station. For first station, what is the wavelength of our first station? 3 into 10 to the power of 8 by meter per second. This is meter per second by 1120 into 10 to the power of 3 per second. Now calculate this one. This is the for first station and second station. And second station. Second station same lambda equal to c by nu. C value 3 into 10 to the power of 8 meter per second. And 98.7 into 10 to the power of 6 per second. Calculate this first one and second one. This second and second both get cancelled. After simplification, we'll get here answer 267.86 meters, and here 3.03 meters, 039 meters. Okay, copy this one and next question. Shall I remove this? Everyone, I am removing this one. And write down one more question. This is related to EMS only. How long would it take a radio wave how long would it take a radio wave of frequency 6 into 10 to the power of 3 per second to travel from Mars to Earth. Mars to Earth. That is a distance of 8 into 10 to the power of 7 kilometers. ఇక్కడ ఏంది, how long would take it the radio wave of frequency, దీని frequency ఎంత, 6 into 10 to the power of 3 per second to travel from Mars to Earth అమ్మ. అది ఎక్కడ నుంచి వస్తుంది, మార్స్ నుంచి ఎర్త్కి వస్తుంది. ఓకేనా, దట్ ఈజ్ డిస్టెన్స్. ఆ డిస్టెన్స్ ఎంత ఉంది, ఆ డిస్టెన్స్ 8 into 10 to the power of 7 kilometers ఉంది. దానికంటే ఆ కిలోమీటర్ డిస్టెన్స్ లో అంత స్పీడ్ తో ట్రావెల్ చేస్తే హౌ మచ్ టైం టేక్ టు రీచ్ ద మార్స్ టు ఎర్త్, అది ఫైండ్ అవుట్ చేయాలి. సో హియర్ ద ఆన్సర్ వుడ్ బి distance to be traveled from the Mars to Earth. To be traveled. Mars to Earth, that equal to 8 into 10 to the power of 7 kilometers. 8 into 10 to the power of 7 kilometers, if converts it to how many meters, that equal to how many meters na? 8 into 10 to the power of, చెప్పండి, how many meters? And their velocity of electromagnetic wave, that we know already, 3 into 10 to the power of 8 meter per second. Okay, already distance came already. And next to velocity also, if you know the distance and velocity, we can find the time easily. The time equal to, what is that? Distance by velocity, that's it. Distance by velocity. My 8 into the 10 to the power of 7 kilometers, that is nothing but 10 to the power of 10 meters only. Into 1000 kilometers to meters like convert చేయాలంటే what we have to do? We have to do multiply with 1000. ఉన్నారా క్లాస్లో? No one are responding actually. Are you there in classroom? Okay, at least try to calculate this one. Say the answer. Distance, how much there? Distance 8 into 10 to the power of 10 meters. 10 to the power of 10 meters by velocity 3 into 10 to the power of 8 meter per second. Meter get cancelled. Now how many minutes it takes? Do it faster. Okay, Akshara. Convert into minutes, Amma. Convert into minutes. You are saying in seconds, correct only. In minutes. Vaibhav Surya 4 minutes 50 seconds ఎట్లా వస్తుంది? 4 minutes 43 also will not come. Four minutes 44 seconds wrong. Actually we'll get here. We cancel this one go. Here we'll get 10 to the power of 2. Okay. If you cancel this one, ఇక్కడ ఏమొస్తుంది? 10 to the power of 2 వస్తుంది. And after cancel this one, we'll get 2.66. Now 2.66 into 10 to the power of 2. This is the seconds. Okay. 2.66 into 10 to the power of 2. Convert into minutes. That is 4 minutes 26 seconds. Four minutes 26 seconds. Okay. Is it clear? No. Copy this one. Next we are going to discuss about the new topic. I am removing this one. Ray, who are options today? They have to give the explanation in front of Mathi sir. Once inform your friends. Or else I will send them to other section also. I will not, and that too I will not allow to write for them. I will not allow to write the term to exam for them also. I'm time pass కోసం చేసినట్టుంది మీరు అసలు మీరైనా నేనైనా కానీ Only another broadcast frequency is 98 megahertz. దీంతో మల్టిప్లై చేస్తాం. What are the wavelength of first station, each station? Okay, and here this is lambda c by nu, and lambda equal to c, we know already the speed of the light 3 into 10 to the power of 8. For first station in the 1120 into 10 to the power of 3. Why? Because this is kilohertz. After simplification we will get this one. And next wavelength of second station c by lambda 3 into 10 to the power of 8 meter per second by 98.7 into 10 to the power of 6. This is megahertz per megahertz. For second station we'll get 3.039 meters. Okay, now is it clear, Arshita? And next keep the heading important one. And next one more important concept, that is Planck's quantum theory. Important concept of this is Planck's quantum theory. Planck's quantum theory. Here the first point, according to Planck's quantum theory, according to Planck's quantum theory, the radiant energy emitted, the radiant energy ఇప్పుడు జాయిన్ కమ్మనమ్మా శివనందన. హలో. The radiant energy emitted or absorbed by absorbed by a body not continuously in the form of small discrete packets, of energy, These packets are called quantum. These packets are called quantum. Some books they may give quanta. Both are same only. These packets are called quantum or quanta. That means, what did you understand from the statement? The radiant energy emitted or absorbed by the body not continuous in the form of small discrete packets. అంటే ఇప్పుడు రేడియంట్ ఎనర్జీ అబ్జర్వ్ చేసుకోవడం కానీ ఎమిట్ చేయడం కానీ అది కంటిన్యూస్గా జరగకుండా డిస్కంటిన్యూ మేనర్లో జరుగుతుందమ్మా. దట్ ఈస్ ఇన్ ద ఫార్మ్ ఆఫ్ ప్యాకెట్స్. దీస్ ప్యాకెట్స్ ఈస్ కాల్డ్ క్వాంటా. For example, light, the emission of light from the tubes also, if tube nunchi tube light nunchi vache light also, that is not a continuous manner, that will emitted in discontinuous manner like in the form of packets, that is called quantum or quanta. అంటే ఏదైనా సరే ఎనర్జీ అబ్జర్వ్ చేయడం కానీ ఎమిట్ చేయడం కానీ కంటిన్యూస్ కాకుండా డిస్కంటిన్యూస్ అవుతుంది. ఓకేనా? ఒకదాని తర్వాత ఒకటి వస్తుంది కాబట్టి వీ కెన్ సీ ఇన్ కంటిన్యూస్ మేనర్, బట్ దట్ బట్ ఎగ్జాక్ట్లీ బట్ యాక్చువల్లీ దట్ ఈస్ discontinuous manner. Okay, and write down next point. In case of light, in case of light, in case of light, the smallest packet of energy, the smallest packet of energy, the smallest packet of energy is called as photon, not proton, photon, called as photon. But in general case, but in general case, the smallest packet of energy, the smallest packet of energy, human will some packet of energy, quantum energy is called as quantum. Called as quantum. The energy of each quantum, the energy of each quantum, the energy of each quantum is directly proportional to frequency of the radiation. Frequency of the radiation. అమ్మా ఇక్కడ ఏంది, ఇప్పుడు ఏదైనా సరే ఫర్ ఎగ్జాంపుల్ which are emits, for example the energy emitted or absorbed by the object. For example, this is object, the energy is emitting or absorbed by the object not in continuous manner, it emits in the discontinuous manner and it can absorb in the discontinuous manner only. Okay na? This discontinuous manner is nothing but it emits in the form of packets, energy packets. This is energy packet amount. These energy packets are called, what we are calling this, quantum or quanta. Quantum or quanta. But in the case of light, we are calling that one photon. In the case of light, the energy packets are called, small packets are called photon. But in the general case, we can call this quantum also. Photon or quantum both are same. The energy of each quantum is directly proportional to its frequency. Yes or no? The energy is directly proportional to its frequency. You know already. The frequency increases, energy also increases. Okay. Now continuously write down. I am removing this one. Energy is directly proportional to radiation. E is directly proportional to nu. That equal to E is equal to H nu amma. Or I will give the explanation for this. Or E equal to H C by lambda. How it came C? Because of nu equal to C by lambda. Yes or no? Lambda equal to C by nu. Obviously, nu equal to C by lambda. Instead of nu, we are substituting C by lambda value. Okay? Did you understand? Actually, nothing there, Amma, here. Listen. Actually, what is this condition? The energy is each quantum is directly proportional to frequency of the radiation. Okay, that means the energy is directly proportional to frequency of the radiation. Is it clear? And we know already that E energy equal to frequency is nothing but that is H nu. I will give the clarity about the H. H is the proportionality constant. Okay, E equal to H nu, and we know that one nu equal to C by lambda. Nu equal to C by lambda. It tells manaki. So instead of nu, we can substitute that one. So the finally energy E equal to Hc by lambda. Is it clear up to here? Okay. I am removing. Anyone can respond, Nana. ఎవరో ఒకరు chat box లో inform చేయండి. Okay, fine. తీసేస్తున్నా. I am removing this one. And the next continuously, H is proportionality constant. The H is proportionality constant. Proportionality constant or that is nothing but Planck's constant also. Planck's constant. That is Planck's constant. So the H value I am writing here. The H equal to 6.626 into 10 to the power of minus 37 kilojoules second, or 6.626 into 10 to the power of minus 34 only joule second, not joule for a joule second. Okay, or 6.626 into 10 to the power of minus 27 erg second. Okay, Amma, here remember some books they will give 6.625, 6.625 or 6.626, both are equal only. Okay, now don't confuse here. The Planck's constant value 6.626 into 10 to the power of minus 37 kilojoule second, or minus 34 joule second, or minus 27 erg second. Okay, if you take kilojoules, that is value of 10 to the power of minus 37. If it is a joules, minus 34. If it is ergs, minus 27. Okay, Now one more. Next continuously point. Not completed Planck's quantum theory. Total amount of energy. Total amount of energy. Total amount of energy transmitted from one body to another, from one body to another, will be some integral multiple of integral multiple of a quantum. Energy transmitted from one body to other body will be some integral multiple of quantum. That value is nothing but E equal to NH nu. That equal to NH C by lambda, or that equal to NHC nu bar. Enduk nu bar? 1 by lambda. Nu bar equal to reciprocal of wavelength. Wave number equal to reciprocal of wavelength. Okay. And where n is equal to positive integer. That is nothing but number of quanta. Copy it fast. Number of quanta or quantum. Okay, na? Completed about the Planck's quantum theory. That's it. Aim ledu, just the energy is absorbed or emitted in the form of discontinuous manner. It told, that's it. Not in continuous manner. The discontinuous manner packets are called quantum. Okay. With respective light, we can call this photon also. Photon and quantum both are same only. And the energy value, and this is the energy, the total amount of energy transmitted from one body to another body, that equal to NH nu, that equal to manaku telusu NH C by lambda, and that equal to NH C wave number.